boron trifluoride, the central atom here is going to be boron, and boron again is not very electronegative, and fluorine is highly electronegative. So this compound is going to be highly ionic in character, but we're going to describe it in a covalent sense because remember there is a bonding continuum. So molecules are neither just covalent or just ionic. There is some covalent character to ionic bonding and some ionic character to covalent bonding. We'll talk about that later. But for right now, boron is an exception because boron has 3 valence electrons and it doesn't need to gain 5 or lose 3 in order to become stable. It actually can form 3 covalent bonds with fluorine. And fluorine has, if you recall, 7 valence electrons. And so what ends up happening is this is a special case. So this is another one that you're going to have to remember. So boron is bonded to the 3 fluorine. And I'm going to draw it this way because, and you'll just see in a second why I'm drawing it this way. And there are no lone pairs on the boron. And since there's no lone pairs on the boron, the fluorine are going to try and get as far away from each other as they possibly can. The central atom is the boron, and the fluorine are the outer atoms. And you can see that since there are no lone pairs on the boron, the way that the fluorine atoms can get as far apart from one another is if they're on the same plane. So, and by the same plane, remember that they're all lined up. Here's our plane, and they're 120 degrees apart from one another. So each of these bond angles is 120 degrees. And the result is the shape is what we call trigonal planar because it's in the shape of a triangle and all the atoms lie in the same plane. So if you have 3 atoms bonded to a central atom where there is no lone pair around the central atom, then the shape is trigonal planar.